So for today, I changed my plans because I realized that almost nobody in the audience knew the evolution of NLP applications such as machine translation. So I think that like in all sciences, we should be interested by the past and the evolution of ideas concerning, in this case, machine translation, which has been called since 60 or even earlier the typical problem, the most difficult problem of AI. That happened around 55, 60. And then I will refer to some evolution of ideas concerning machine translation. Okay? So what we have done after that evolution, which I will actually present in the second part, because I would like to present some project that has been active and has influenced a very recent project in extraction of guaranteed meaning from specifications. Okay, so the history is that during the 60s, say, researchers wanted to, ça marche pas, hein? Replace the translators, and simply get translations for information, not for producing good translation. So the projects in America were actually centered around the GATT project, with the first experiments in 51, and then Cyran from 67 onwards. And the only application at that time was rough machine translation for military analysts in the Wright-Patterson Air Force Base. Okay? So this, there has been some evolution I will describe later, to a point where in Grenoble we had a full-sized machine translation system based on 600,000 pages of corpus, kindly given by the RAND Corporation, and giving results which were deemed to be quite enough for analysts speaking Russian to be given the original text, knowing they were interesting. So the idea was to extract interesting things and decide by non-Russian speakers that they were interesting, and then go to send them to analysts who spoke Russian themselves, right? So when we did that, in a way, we had done progress on many frontiers, like the use of the three-part organization, that of a compiler, so analysis, transfer, generation. Okay, we had developed several specialized languages for the linguists. So the linguists were now programming, say, not the system analysts, etc., informaticians, as we call them, or software specialists, who simply build the tool and the development, a linguistic development environment. Okay, and then we saw that this was very good, could be useful for the army, etc. We had several parallel projects with the Ministry of Defense. But now we asked what could be done for the casual translator, and also for translation into many languages, like is and was found in technical documentation. Okay, so idea became to build a system that could be used by authors in their source language, marche pas, hein? And then, in a way, post-edited if absolute professional quality was needed, but we wanted to try to have systems that could be used by general users in general domains, not necessarily in subdomains like rockets or explosives, etc., which we got from Russia and we wanted to translate for the army. Okay, that was a turn around 70, 72, exactly at the moment where Esprit projects were started at the European community. Okay, so the idea became to try to replace analyzers giving answer yes or no and giving one translation in a heuristic way, replace them by a system who would process ambiguities and do ambiguity detection and resolution automatically if possible. So very often you have ambiguities of classes, etc., which can be automatically resolved, but there are other ambiguities that will remain. You will have several linguistically totally possible representations, because here we have to define what an ambiguity is in the computational terms. Okay? So ambiguity computation. Then it began the project with Hervé Blanchon, Mutsuko Tomokyo, and a few others, became to turn around the definition and processing of ambiguities. So I will just give you an idea of what we built as a prototype to do interactive dialogue-based machine translation for general authors. Alors, c'est très bien. So the goal is what I said immediately before. MT for technical writers not able to translate into one or more target languages. In aviation, for instance, it was necessary to have the documentation first, in our case, written in French. Then for the general market, it was translated into English. And then from English, it would be translated by Air France, for instance, to the languages of the engineers and technicians who had to do the maintenance on many sites. Okay? Ah ben alors. Okay. So the idea was then not to decide too early, produce factorizing representations, and do interactive disambiguation to be sure to get the intended meaning, not based on statistics, because that's amenable to very fine distinction, and it cannot be done in principle. Very often it depends on the situation. Okay? So, does it work? Yes. So this is something I did with Mutsuko Tomokyo, who worked at the time in ATR, where I spent 1 year. Okay. So, when should we do interactive disambiguation in the translation process? Not too early, not interactive disambiguation like Alps and Weidner and Tao, etc., who would ask a question at the first choice point. But that is really stupid, and the translators or linguists don't like that at all, because very often those ambiguities are automatically resolved later if you have some parsing algorithm, maybe based on a context-free kernel or whatever, where you begin to build partial structures, and only at the end, some possibilities just fall down. Okay? So, not during automatic disambiguation, but just after, say, when we produce the multiple result for analysis in syntactic and semantic representation. Okay? Now, this I quote. So, the method is to generate disambiguation dialogue. So you are on Macintosh preparing your documentation, and you have put in some text container a sentence, maybe a requirement, or maybe a description. Okay? Then you would hit a button, say, this is ready for interactive disambiguation. And you continue to work. And after a while, the linguistic server will come back and tell you, now you can answer the questions. We have prepared some data structure, which is, in a way, a tree of questions and answers. And then when you will have done that, we will send back to the server to do the rest of the work that is transferred into a parallel representation in the target language or languages and generation into that or those languages. Okay? Alors, okay. So there are two notions of ambiguity. Really, when you ask people, they say, oh, and we have ambiguity when I understand two different things, or where two different humans understand two different things with the main text. This is not manipulable. What is an ambiguity? It is when. So first of all, we had to elucidate what kind of object an ambiguity can be defined as. Okay? So formally, we will say that first idea is to say that we have an ambiguity for a sentence or a text fragments like a title, etc. When we find two different representations for that fragment or subpart of the fragment, anyway, two different explicit representation in your representation system, meaning you have to have a representation system. Maybe trees, maybe feature structures, maybe whatever, semantic graphs, etc. You have to have that. Okay? But it's not enough to say when there are two different, because some ambiguities are vague, like reference of pronouns can be not presented as a list of possibilities, but as a question mark. Okay? So we have to define that like that. So, when you have a dialogue, we have first to realize that very often we have segmentation ambiguities in dialogue acts. In a turn, sometimes you have two of them. I will have an example at the end. I will show you an annotation of a transcription of a dialogue. And for the turns, you have ambiguity of segmentation into utterances. So the person begins to say something, interrupts, and continues. Is it still the same utterance or not? So at the utterance levels, we will say that there is an ambiguity if we have two different analyses, so data structure, for the same fragment of text in the segment, say, in the context of a certain generic task. That's quite important, because there are ambiguities for which we will simply consider that two structures will be equivalent. Why not? For instance, if I have a list of things, I might have a vertical list to the left or a vertical list to the right, and it's a convention by the grammar writer that they would be the same, simply some reduce. I mean, so the list reduce better from the left and others from the right. Okay, so we consider the fact that the ambiguities are defined by the results of a reasonable, up-to-date parser. Otherwise, maybe when you prepare a system like that, you don't describe all ambiguities first, but you will build some kind of grammar or analysis system, and you will know what kinds of structures or substructures are produced, right? I take an example showing the necessity to consider utterance level ambiguities in the context of the full utterances. Take, for instance, the sentence, do you know where the international telephone services are located? So here you see you have an ambiguity of attachment. International telephone, and then service, thank you. And the other one, international telephone services. Okay. So if you take only that fragment without the context. Now, if you add to the left the article the, so now you have two fragments, the international services, then there is no ambiguities. You see? Services can only be a verb in the context of services, many countries. Okay? But if I increase again the context, then the ambiguity reappears. Okay? So it has some meaning to speak about the ambiguities only within the context of a full utterance. Okay. It's a bit difficult. Are you sure you don't have a problem with the other side of the cable? Okay. So, we have to consider computable representations. If I cannot compute the representation, it has no meaning to want to handle ambiguities as objects, which is a goal. Okay? So a reasonable parser has size and time complexity to be tractable over the class of utterances. And if you take now the systems like LLMs, etc., with billions of coefficients and many more billions of data, it's not really what I call tractable. Of course, it's really too much. And then you have to have reasonable assumptions about the complexity of the full, say, grammar or parser you will build. You have to make projections like if it is complexity is in O over N4, forget about it. But if it is still O over N2 or O over N, like with some algorithms like Euler's algorithm, then maybe the constant will be high, but it will be or become tractable. Okay? So a representation will be said that is a mathematical notion. It's not simply, there's ambiguity when I can distinguish two meanings or when two different persons understand different things. Here, this is a mathematical definition. Okay? So I say we have an ambiguity if we have an presentation is multiple or underspecified.
Sorry to break your definition. What kind of notation or labeling
we will come to that here. Okay, thank you. So, for instance, here we read books. Suppose we have this kind of representation when tense is either present or past, is a disjunction. So here I will say that this is not proper. There is an ambiguity there. I have a single representation, but still it's a kind of a notation to express the fact that I should derive two proper representations from that. And there is an ambiguity to be solved there. So according to the representation system, this counts as an ambiguity. Okay? So the representation R of a certain sentence, turn, utterance is ambiguous if it is multiple or if the set of its proper representations, sub-representations, contains an underspecified element. Now, we define the notion of minimality, which you can read, a minimal underspecified part of P if it does not contain any strictly smaller underspecified part Q. So we want to try to get what we would call the support of the ambiguity as small as possible. Okay? The scope of an ambiguity of multiplicity n is minimal. No, first of all, I have to. There is nothing. Oh, yeah. So, a fragment V of U, which is the utterance of multiplicity n, is an ambiguity of multiplicity n if U has n different proper representations which are part of n or more proper representations. And V is an ambiguity scope if it is minimal relative to that ambiguity, like international telephone services in the full sentence. This means that any strictly smaller fragment of W of U will have strictly less than n associated sub-representation. So meaning with that definition, we can extract the minimal ambiguities and from there generate question-answer dialogues where you will answer by choosing possibility 1, 2, 3, or default. Okay. So you see this representation, as I said, is not anymore because of the Z, but we get the minimality here of that part of the subgroup, international telephone services. International telephone services. This is what I will call the minimal attachment ambiguity in that terminal phrase. Okay. This here is simply the same idea with a dependency representation. Okay. So an occurrence, ambiguity occurrence, or ambiguity, the object. Now this particular object, which I can label in transcriptions. Well, okay, I have a mathematical definition, but Actually, for this talk, we will not detail that one. But here, no, I cannot. Ah, yes. Okay, this diagram explains this better. Right? Okay. Now, the kernel of ambiguity is the scope of the ambiguity, which cannot necessarily, which can be connex, but not necessarily. In particular, if you have verbs with particle in German or even in English, you can have a scope that is not continuous. Okay, ambiguity type is the way in which the PI differ, and this must be defined relative to each particular representation system. Like we have seen in a system based on constituent, we have that kind of ambiguity of attachment, but it is represented in another way in the subtrees of the dependency structures. So this is something you have to elucidate, categorize ambiguities according to the representation system you have chosen. Okay, now to do ambiguity labeling, we have to have some kind of formalism with tags and values, etc. This is what we have done here. Okay, so label piece, label text, or label dialogue, label text, text header, full text, label paragraph, etc. This will give me something which I can produce as JSON or XML if you want. Unsure utterance, for instance, I have put that here. If you have label terms, it's a simply plus is the usual notation with extended context-free grammar. So everybody knows that context-free grammar notation. You know, if you study theory of formal languages and automata, you did or you did not? Silence. I will start from the assumption that you did not. So, ambiguities of segmentation, this interests you. So this is what we found with Kutsuko, a very easy way to represent them. So A, maybe segmentation there. B, maybe segmentation C. So here we have our doubts about segmentation. And this one means that it could be, there could be a separation between B and C, A and B. But we cannot have ABC if we have that, or A separation, B separation C. So if you produce a graph with that, you find you have different possibilities, but this is very shorthand. Okay? So, okay, so go back, and is this number 3 right there? Shall I wait here for the bus? You see, it's quite easy to annotate for segmentation ambiguity. So, another example for the lists. Well, it's a guide actually to annotate level. So, the scope will give a text, the status. So, easy, something interesting when you consider ambiguities is whether they are important or not. So, if they are not important, you should not even produce questions about them. You don't want to go to perfection and then the user is pissed off, I would say, in English, and does not want to continue anymore to answer questions. So that's quite important to know, if possible, which ambiguities are really necessary to be solved and which are, say, less important. So crucial, important, not important, negligible.
We need the microphone.
Ah. Did you hear or not? Ah ouais, d'accord. Okay. The type name value structure, attachment structure. So maybe you have an ambiguity of a structure, maybe an ambiguity of attachment, maybe, and this is the main two main ambiguities which we do at the level of the tree structures, if this is what we produce in a packed way. Okay. Now, we have also put here the morphosyntactic class, because sometimes there is a doubt about the class or the number, and it's enough to decide between, say, singular or plural. Sometimes it cannot be done automatically, so you're still with the two of them, or like in my previous example with read and read, tense was present or past. Okay? So, adjective, adverb, etc., might be and are very often ambiguous in English. So if you will label the piece, if you have, say, time flies like an arrow, you could say time is a verb, it's imperative of a verb. And the other questions will lead to the fact, okay, that the rest is simply the complement of the verb time. But if you have time flies, where flies is a verb and time is a subject, then it's different. You could simply annotate that flies is a verb, third person. So, well, here is an example. I'm sorry about the presentation, it was a bit collapsed, but it is quite easy to follow because the characters are bigger, right? So here, this is a dialogue called ME. We recorded lots of dialogues for ATR to try to pave the way for the development of interactive spoken translation systems. Okay? So labeled dialogue ME10A, that's simply the number, the title of the dialogue. Good morning, conference office, how can I help you? Ah, yes, good morning. Could you tell me please how to get from Kyoto Station to your conference centers? So this is a transcription where you get, including errors, like A, yes, I am to attend the Second International Symposium on Interpreting Telecommunication. So the on was not clear, so this is the result of ASR, simply. Okay? Then you see it's quite, if I take yes, at Sanzo Station you will just change trains and get on the subway that are the Keihan Kyotsu line, which will take you close to the International Conference Center. Okay? There is a lot to be labeled there. Okay. And for turns. So, what for EMIT 12A, for instance, we find scope, your conference center. So this is a labeling. Huh? The type is a structure, ambiguity of structure, between your conference center and your conference center. Same ambiguity of attachment as before. Importance here is negligible. What does it make? We take whatever we want. So the system will simply take the first one to continue processing. And turn, end of turn here. Turn is not necessary if there is only one utterance with no ambiguity of segmentation, of course. So this is not interesting. The Japanese, that's for you. So I am to attend the second International Symposium on Interpreting Telecommunication. So ambiguity for this one, M2. I forgot why we have a 5 over there. Okay. And the status is user, and Japanese koto ni natteiru, something like that. Importance. It is important. Okay. Or then, in maybe then. Where are you calling from right now? And the status is expert system. And importance is crucial, etc. I don't remember why we have this from the ASR, but this is what we get. So this is an utterance because of the breath here. And then to get to the International Conference Center, you can either travel by taxi, bus, or subway. Okay? And it is importance of the ambiguity. Where is the ambiguity here? It's the scope of CAN. The scope of the ambiguity is the model CAN itself. Why? Well, because can be a model, but it's also a verb. Can the beer, So, of course, it is crucial, but of course, it is an ambiguity that can almost be automatically resolved if we know the type of text, the domain, etc. Because here, probability that can has the second meaning is very low. Here I have to say something which is very, very important. Quite often, linguists show you examples of ambiguities, and for that they extract or they build these examples, and the people they are talking to, like you, will tell me, but this is invented. It does not appear in reality, that kind of ambiguity. And they are wrong. And the fact is that if I detect that kind of ambiguity in a text or dialect transcription, it is somebody, some persons will not even see that there is an ambiguity, but if I take it out of context and show it to you, then you will see, it is invented, it is a garden path sentence. So why should we worry about that? Why? Simply because they are really present in the text or transcriptions of dialogues, and you have to worry about them. Sometimes you have ambiguities concerning the scope of negation. It's very important that you realize there is ambiguity and you make it explicit, and make the scope explicit. Ich wasche keine Wagen. Ich wasche die Wagen nicht. Means I'm clean. I clean the cars. I don't clean the cars, or I clean no car. It means totally different things, because in one situation there are cars to be cleaned. In the other one, it's simply that you don't habitually clean cars. You are not a car cleaner. What happens again? I swear I did not do nothing. So, Tai or Becky, I want to. Same thing. Very often you have ambiguities about modal verbs in those transcriptions. To want to, etc., is quite ambiguous. Okay, I will take it that you see probably how it can be done. So now we have ambiguities as objects, which we can extract from a text to train then or to aid our developers to produce those ambiguities with their parsers. And then we would automatically generate disambiguation dialogues. I will continue a bit with that. So now, what is the general il n'y a pas d'eau là. I would like to have some water. What is the general diagram we envisage for top quality, granted quality translation based on interactive disambiguation and into possibly several languages? Alors, maybe it's the other file. Yeah. Uh-huh. No, I have to do that. This is a Word file. I lost the... That's better. So, bit complex diagram. So, what did I say until this moment? That we start from a source language text, then we get a presentation containing ambiguity marks, okay? And we produce here a multi-level, multiple constituent structure. The first attachment structure we have seen, it was a constituent structure with non-terminals over the internal nodes. Okay? So produce that. On basis of this MMC structure, we will produce a disambiguation dialogue. Why do we do that at that level and not later when we will obtain abstract structure? Because the MMC structures, the constituent structures, are projective, means their correspondence with the text is without crossing links. Okay, in other words, you can read the text from the leaves of a constituent structure very easily, so that when you see there is an ambiguity, it can be represented quite easily. Okay? So after interactive disambiguation, you will have chosen one unique multiple level constituent structure after disambiguation. So if disambiguation process has not run to the very end, you simply choose the first possible structure and continue. Now, there is a phase of transforming the constituent structure, multiple level, that is containing several levels of linguistic interpretation, like functions, syntactic functions, deep syntactic functions, predicate arguments, and also the semantic relation level. Okay? So from that UMA structure, you produce what I call generating multi-level abstract structure, generating multi-level abstract for target language 1 here, and for target language 2. In the Lydia project, we produce from French structures in English, German, and Russian. So we got 3. And then we realized, and then this was done, demonstrated, etc. Then you will tell me, but what happens on the target side if you have resolved an ambiguity in the source language, but there are still ambiguities or new ambiguities in the target? That can happen. The ambiguities are not just transferred one-to-one between languages. Very often I gave the example from English into French, for instance. Replace the device after cleaning, or you should replace the device after cleaning. So here, replace can be translated as, in French, as 2 different verbs, replacer, remplacer, which means to put back in its place or replaced by a new one. Okay? And so if in French I generate the first one, I may cause an accident, because in reality I should have replaced by a new one. And actually, many accidents have happened in reality because of that. So you get a choice that is done by the machine, and you are not warned that there could be other possibilities. Okay? So now the idea here is that to avoid this and to get also the memory in source of what interpretation you have chosen at the end, you should not forget about it. Otherwise, the reader, another reader of your text will maybe in his head understand another meaning than the one you intended. Okay, so I continue where I was. Then what is planned to solve this problem? The idea is that to reanalyze the results. Quoi, qu'est-ce qui se passe encore?
We remove that. You cannot use.
Ah, okay.
Plug it.
Okay. Qu'est-ce que c'est que ça, là? Okay. He plays havoc with my system. So again, okay. The idea is to reanalyze in the same way the outputs in language 1 and in language 2 and in language 3, etc. In the same way means with a similar parser, with the same conventions for the representation system. It does not have to be universal dependency. It can be simply an adaptation of your representation system you have used for the source language. So in any case, you will produce a multi-level constituent structure. And here, the good news is that you can, in principle, run the interactive disambiguator for language 2, or for the target language 1 or target language 2, because you know for each answer, for each question, you would know the answer, which is the one that selects the generating structure from which generation has started. That one is not ambiguous, okay? So, here, you do interactive disambiguation here, but it is muted without the user. No user is needed here. Okay? Then you get your UMC structure because you know that in the generating process you have started with an intermediate structure that is exactly of the same kind as during the analysis of the source text. Okay? So here you can have the disambiguation and you can make, and this we implemented actually, back translations. That's often very important to have back translations into the source language. And if it looks bad, something has happened and you should not continue with that result. You should reformulate, you should whatever, but there's a problem. And actually the technique of back translation, we have used it a lot for the C-star project of machine translation of, how do they say it? Not targeted, but spoken dialogues or task related, task attached, spoken dialogue. It has been proven very effective in actual experiments, like one that was done on Thursday, 22nd July, 99, with ATR in Japan, ETR in Korea, and University of Karlsruhe, Grenoble and Geneva and Lausanne, and the Italians were part of I think 5 languages. So it was really useful to be able to have that and to say, oops, this was not what I wanted to say, so I will rephrase, maybe add, say, hello, good day, how are you today, Mr.? So havoc. So you rephrase, hello, this is Mr. So-and-so. How are you? Now we have suppressed ambiguities of segmentation and we can get very small and correct linguistic forms. They call this interface format, in a kind of pivot but attached to the task. And then you can get good translations in all the other languages. Okay, I have something now on UNL, the pivot-oriented project, semantic pivot, and the history of machine translation leading to the choice for that project, and a kind of presentation of what the UNL representation is. And I think it's far better as a semantic graph representation for natural language content, far better than AMR, but we might discuss that afterwards. Okay, so this is a talk I found, there were some images missing, but I found them back just before I did a further attempt tomorrow. And so this was done in 207. That was a part of the second step, say, of the UNL project. And I can use it to do a justification of doing machine translation using a pivot representation, a semantic pivot representation, and describe to you what is the UNL graph language and how it would still be used in many, say, up-to-date projects to be a kind of intermediate representation enabling multilinguality. Okay? Je vais regarder avec ça. Okay, so I'll begin with a review of empty architectures. I think you don't know that at all. As I said yesterday, the fact that in 85 there were about 30 commercial, operational empty systems in Japan with different architectures, etc. Then the UNL architectures, and UNL can be understood as a language, say, of semantic graphs that are in reality mathematically hypergraphs. I will show what it means to be hypergraph. And they are Anglo-semantic because the symbols for semantic relations are taken from English, and because the symbols to denotate concepts are built around English headwords and semantic restrictions. Right? They are not concepts. They are concept denotations. That is different. Okay? And we did, I don't know whether we'll go to this one, but we made a really experiment to assess the possible usefulness of UNL within the context of multiple target machine translation. Okay? So, first of all, when we consider machine translation is to have in mind which goal we pursue. Production of high-quality translation by bilinguals, that is, to equip somebody to become the equivalent of a professional translator. Or simply understanding text or speech in some unknown language. So this is assimilation, and maybe we can measure the adequacy or the number of buying acts if the application is to present pages translated with machine translation to potential customers. So that's a good measure. If it is in their language, they click so many times per week, say, But if it is in another language, it will take them more time and they click less frequently. They buy less. Okay? Then 3, production of high quality translation from an unknown language. So that's the application we had since the very beginning for the military at Patterson Air Force Base, and at some places in the Soviet Union, but really they were very, very far behind, because they had no good computers. And then production of high quality translation into unknown languages. So here we need, for the last 2, we need some human time to do post-editing or to do something, because the high quality will not be obtained automatically in a totally different context. Okay, so the architecture, I say they are linguistic architecture, computational architecture, operational architecture. So linguistic architecture is simply what we choose for intermediate representations, linguistic representations, during a pipeline of process from a source text to a target text, say. Computational architecture is different. It's about programming paradigms. Do we do direct programming? Even if it is in Lisp, but it can be done with ruled automata, etc., like Lingual, for instance, in Japan, or like the Mu system, influenced by the Aryan system in Grenoble, etc. So programming paradigms, and whether the algorithms, the computations themselves are based or not directly on a corpus. Since the very beginning, people have used corpora to develop machine translation systems. That, of course, everybody has to use corpus. But you can use directly a corpus of examples for translation, for instance, translation by analogy, by Yves Lepage, or with some computation before you run, like in statistical MT or neural MT, then the learning is much bigger, much more costly, okay? And you can have, of course, so SMT means statistical MT, PSMT, post-edited semantic MT, EBMT means example-based MT, with several variants. So, these are all the choices in yellow of the different linguistic architectures for MT systems. So, direct translation from graphemic level was actually not done until the LLM arrived, I would say, which are really based on the graphemic level, and until Yves Lepage translation by analogy was made. That was in from 1896 to 2005. Okay, so semi-direct translation with, say, morphological analysis was found to be necessary for Russian English at the very beginning. So we had that level, okay. It's semi-direct because simply then you do what I did for my first year of PhD, active reading thing, that is you do some morphological analysis and you do some movements for some groups, like moving the adjective after the noun in French when coming from English, things like that, and choose in a dictionary, maybe have some transition probability statistics about the probabilities of transition from one word to, or one lemma to the next, and that's all. Okay? So there are no systems really operational at this time of semi-direct translation, but I remember at class 1 at by Uchida also, at Fujitsu in Tokyo, before 80, yeah, around 77, 78 already. So that was such a system because the structure of the two languages, Korean and Japanese, is so near that it is possible it gives you surprisingly good results. Now, the other one. Syntagmatic level. So at that level, you have only C structures, but very soon you add a semantic tactical functional level, which is a deep agent, for instance, and not subject or co-agent. You have representations which mix classical semantic functions, syntactic functions, with semantics like epithet and attribute or qualifier. Qualifier would be more said to be semantic. Okay, then we can mix the levels, that is, in the tree structures or graph structure you produce, you put information about, say, tense, which is at the level of syntax, morphosyntax, and time, which is at the semantic level. And you will have them in the same linguistic object. So we can have also, what do you say, ascending transfer. It's where you go to the representation of the other language. No? Okay. You suppress the lower levels of linguistic interpretation. And this is the way we get to the generating multi-level abstract structures, okay? Because we don't use directly the syntactic information about the source language. We recompute from the higher levels of linguistic interpretation. We recompute the NPs, for instance, the classes, the syntactic classes like NP, VP, etc., from the top. So we reconstruct, in a way, a concrete structure from an abstract structure. Okay? That is what it means to do ascending transfer. Now, at the logico-semantic level, you have semantic transfer. That is exactly what was done in the new project of machine translation in Japan between 82 and 87 by the group of Professor Nagao, Tsuji-san, Nakamura, and 15 Japanese companies who sent people to work with the Nagao lab and took turns to develop their own systems. Okay? That actually explains how they came to have about 30 commercial operational machine translation systems in Japan in 85 or 86. At the end of this new project, actually, many companies, a dozen or 15, did begin to work on MT at the beginning of that project, 82. Okay? And then there is interlingual level and conceptual transfer, which is actually what we want to do if we have an intermediate semantic and pragmatic presentation, plus possibly an ontology to interpret really in terms of a knowledge-based representation. Okay? So, I will not detail all of that, but take a look. I think it is big enough. Can you read from where you are? Can you read? Okay, so you have rule-based machine translation. You have FST, means finite state transducers. Okay, so this was for very near languages, like I say, Hindi and Urdu, actually, same thing. But actually, they are languages, they are sub-languages of the macro language Hindustani. Japanese, Korean, no, they are similar, but so for statistical MT that began in 80, on the basis of some early intuition that translation could be done by considering the problem as a decoding problem. Suppose somebody took a text and translated it into Russian. Now I have Russian. And I imagine I would decode the Russian text and find the or one of the possible source texts. Okay, this is the intuition behind SMT systems. Okay, and then example-based MT began a bit later. So no pre-processing. This is for if the case is of pure EBMT. So analogy resolution and n-gram filtering give results that were in 2005 in ACL in Phuket, I think, gave the same quality. I mean, the blue, etc. Where if you take the same measures, okay. Now, semi-direct translation systems. The first generation, well, we had the Georgetown system, which actually continued to 73. So I learned that after I wrote those slides and I forgot to change. And it was replaced by Cyran in 73 or 74. There was Panam and Paho, very good system between English and Spanish on document on health. And Global Link, I don't remember it as a good system, but now you see analysis transfer generation can be done with the same kind of paradigm. Like here, procedural, or statistical, or you can have rules. Okay, usually the developers adopt one computation paradigm, but it is not necessary. Alors, it doesn't work. Okay, so you see lots of other systems, descending surface syntactic systems. That means that you get to syntactic presentation, and then you mix transfer and generation in the same phase. Okay? The metal system was of that kind, actually, when I mentioned yesterday. And you have here RBMT also, but different with slot grammars in Prolog. which does recursive descent, but that system, here LMT logic-based machine translation, actually has been taken out of IBM by a small company who actually grew and developed horizontal architecture. Company was called Linguatech. I think it still exists with two branches, one in Heidelberg and one in Munich. So, well, the basic software is in Prolog. Actually, Professor, who is it? There's a professor in Japan who did Lingol, remember? Tanaka from Institute of Technology of Tokyo. So he did the first version of Lingol in Lisp, and then a second one in Prolog. And Lingol was the system development environment used by KDD for the CADE project, Professor Sakaki. Remember? I think something is wrong, but voilà. Yeah. So I will not read every cell. So lots of things really have been tried. And then for multi-level transfer systems, not much. Extended context-free grammar. This is meant by this. This is done by Verli in Geneva. I did not put his name, but this is a good system with 4 or 5 analyzers and doing machine translation effectively using the context-free structures modified by the latest Chomsky theory of move alpha, etc. So when you co-index, you use co-indexation to keep projective structure while also representing the movement of elements with respect to deep structure. Very linguistically oriented, but it worked. Now, semantic transfer system, I mentioned here Mu system in Japan and Majestic Jixt. Majestic built from the Mu system, which was developed, as I said before, at Kyodai. It was called the National MT project in Japan, the Mu project. Well, Mu means, in Japanese, if I am not mistaken, a dream and a void. So, you understand what you want. And conceptual transfer systems are less, but I will concentrate on UNL. But before UNL came Atlas II, invented by Hiroshi Uchida, who invented UNL as a progress over the completely closed system of Fujitsu Atlas II. And then systems with explicit understanding, KBMT 81. So you see the use of ontologies in machine translation is not yesterday. Now it is considered for tomorrow, but actually it has been prototyped in 89 and deployed at Caterpillar for 15 years, from 92 to at least 2005 or 7. Sys2 and for systems for task-oriented dialogues have been also using the same kind of semantic presentation, semantic pivot, because of the constrained nature of the task, of the like information for tourist information or booking or whatever. Okay. So this is putain, c'est pas vrai. Oh, that slide is damaged. Well, not too much damaged. Not too much.
It's quite long already. It's 1.5 hours.
Yeah, okay. Just I have 10 minutes for showing UNL graphs. Yes? So we lost a lot of time because of this connection problem. So I will give you a few examples and stop there, okay? So, UNL graph is not always a tree. The dog watches his master. So the symbol in the squares, like watch, dog, and master, are incomplete here. It's a shorthand. But you see, you have semantic relations, and the total is not a tree. And this is the linear format for that, where you enumerate the arcs. So on an arc, on an arc you have semantic relation whereby the arc, and then lexical unit, which is called a UW. Here, this is not only watch, but watch with a restriction list includes do, it's a kind of do, a kind of action. Agent is a kind of thing, object is a kind of thing, and dot entry means that it is the entry point in the graph. And then the second element at the point here of the arc, of the agent arc, is dog. A node, dog, and this is UW for the dog, ICL animal, and then an attribute, semantic attribute, definition. So not a dog, but the dog. So something, watch is master. So here master is the object of watch, and then possession of dog is the master, his dog. So you see that's quite okay already to be able to represent structures which you cannot represent by a tree usually, without duplicating nodes or doing things like that. So now another one to show what it means to have hypergraphs. John knows that Peter will not come and regrets it. So this here is the graph, part of the graph here, with entry point regret. So John is the agent of regrets, and John is also agent of no, and you have an and between the two, and object is 01. 01 means this one, which is a scope, they call it a scope, which is Peter comes, right? That is the way to produce something. Now, if we want to build this using classical methods of NLP, we will build trees and in a way flatten, in a way put back the duplicate nodes together. Okay? So any UNL graph can be unfolded in an auxiliary UNL tree, which makes it possible to use classical tools oriented towards tree manipulation. Okay? So the same example, almost. Isaac sees that an apple falls and he explains it. Right? So we have exactly the same as the example before, but now we can unfold this one, and I have Isaac 01. Okay, 01 is actually the number associated with each arc of the subgraph. Okay? Okay, so in this way, what I have done here is to put to duplicate the Isaac node into two nodes. Okay? Now for the semantic relations, I will not go through them, but there are about 40 of them. It's a matter of choice, of course, but it's rich enough to represent everything we want. We tried it on large corpora. Okay, then the attributes are either semantic or pragmatic. Okay. And now I conclude with one or two examples of how you would write a UNL graph quite easily after 1 hour of learning how to read the specification and going through some examples. Actually, I did that with my students for 10 years at the Polytech, asking them to write UNL by giving them the UWs to be used, and success was quite good. It's much less difficult than to write linguistic structures that conform to some particular grammar with lots and lots of symbols. That is, in a way, more economical reasons. And we have to understand that actually, when we produce a UNL graph, we translate in our head into English, and then we produce a structure, an abstract structure of English, right? Ah, qu'est-ce qui s'est passé encore? Qu'est-ce qui s'est passé? Yeah, here. I wanted to give you this one. Okay, another complex example this time, and I stop. It provides a content management system that allows native speakers to write, manage documents, and offer online payments in the Inuit language. Now, if I ask you to write a linguistic dependency structure or constituent structure for that, it will take you well over 1 hour. Okay? So, but here, it's quite easy. It provides, so we have no apparent subject in the presentation because it is a semantic representation. Okay? So what we put in place of this is the replacement, the anaphoric referent, which is in this case at a weak network. Okay, so the it actually is not it here, but atavic.net I see an entity, a UW, describing, copying the UW of used in the previous sentence of the same paragraph. Okay. Provide what? Provide object, a system for goal, for a system, because in defining goal, managing manner, content. So somebody has put mode here, and I said no, it's more manner. Okay. Content management, okay? System for content management here. And a system to do something, that is the goal here, to do and manage. So here I have a subgraph here, okay, a scope, where this one right is the head. This is a convention when we have the hand here, and people usually forget that they use the Japanese order so that the arrows go to the left. So write and manage volitional agent. So there is behind not an ontology, but what I called a pre-ontology of the UWs. Okay. And now they provide a system for speakers of native, for native speakers, if I see here, for native speakers to write and manage, okay? Sorry. Okay. Okay, so one thing which is good here is that it is visible that we made the first time we made a mistake on the orientation of this arc here. Okay, but also something is interesting. We can represent the ambiguity, attachment ambiguity here by saying it's write and manage in the language or offer in the language. You see, here I have one structure, presentation structure, where actually you see two possibilities of instrument. Maybe it could be understood as both, but normally speaking, one interpretation is the good one, and we could develop some ambiguity handling mechanism for that kind of graph, because it's evident from the graph themselves that there are ambiguities of attachment, for instance. The case here with this, and we can also correct, get that representation with payment online, and asking the user whether it is simply online is like an adjective qualifier, or is it a method to do something, in case it should be a manner, maybe. But anyway, it's amenable to direct processing. Okay. So yeah. The last one is to show you how we can build machine translation systems that can reuse components developed with different linguistic architecture, different conventions, and different computational architectures. Some might be rule-based, some might be example-based, some might be whatever, LLM-based. We don't care. The idea is that it is very important to go through UNL as a bridge on which we can also explain some things, because it's quite feasible to go back, to trace back the representation from the generated output text to the UNL above. Okay, I think I will stop there, but I hope it shows you that there is still some research to do on machine translation, even if there are LLMs there, because you could use them to produce some parts and maybe to produce dialogues also. That's really something they can do. And it's a delicate work for humans to write disambiguation questions in this good order, etc. Okay, I stop here.